Right now, at this exact moment, somewhere in the world, someone is opening a bag of potato chips. Actually, not just someone. Every single year, humans consume over 5 million tons of potato chips globally. The global potato chip market is worth over $40 billion. And on Super Bowl Sunday alone in the US, 11.2 million pounds of potato chips are eaten in one day. One snack. One day. 11 million pounds. But here's what almost nobody thinks about when their hand reaches into that bag. What actually happened to that potato? Because between a raw potato sitting in the ground and that perfectly golden, impossibly crispy chip in your hand, there is a factory process, so precise, so technically demanding, and so carefully engineered that one wrong temperature, one wrong slice thickness, one wrong oil level, and the entire batch is ruined. And the history behind how this snack even exists? It starts with an angry chef, a bad-tempered act of revenge against a fussy customer, and an accident that accidentally created the most popular snack food in human history. Today, I'm taking you inside all of it. The invention, the science, the full factory process from raw potato to sealed bag, and the one chemical that every potato chip factory in the world is fighting to keep out of your bag without you even knowing it. Stay with me, because once you understand what goes into making a chip that crunch is going to hit different, the invention born from an insult. The 24th of August, 1853. Saratoga Springs, New York. A wealthy railroad and shipping magnate named Cornelius Vanderbilt is dining at Moon's Lake House, one of the most fashionable resort restaurants in America. He orders fried potatoes. They arrive thick, soft, exactly like French fries. Vanderbilt sends them back. Too thick, too soggy. The chef, a man named George Crumb, of Native American and African American heritage, does not take this well. He is furious. So he does something petty and deliberate. He slices the potatoes as thin as humanly possible, paper thin, fried them to a hard, brittle crisp, buried them in salt. His intention? To make something so extreme, so impossibly thin and crunchy that the annoying customer would have nothing left to complain about. He sent the plate out expecting a fight. Vanderbilt loved them. The other diners at the table loved them. Within days, Moon's Lake House was famous for its Saratoga chips. George Crumb had invented the potato chip not as a culinary achievement, but as an act of pure irritation. Within decades, the chips spread across America. By 1938, Herman Lay began mass-producing them in Tennessee, laying the foundation for what would become Frito-Lay, largest snack company on earth. Today, Frito-Lay alone produces Lay's potato chips in over 30 countries, and globally, potato chips are the #1 selling savory snack in the world, all because a chef lost his temper in 1853. It starts at the farm, not the factory. Most people assume the potato chip story begins when a truck arrives at the factory. It doesn't. It begins months earlier in a contracted field with a very specific variety of potato. Not all potatoes make good chips. In fact, most varieties make terrible chips. The best chipping potato varieties, Russet, Burbank, Shepedy, and Atlantic, are specifically bred and grown for one purpose. High dry matter content, meaning less water in the potato, which means less frying time and a crispier result. Low sugar levels, this is critical. And here's why. When a potato with high sugar content is fried at high temperature, the sugars react with the amino acids in the potato through a chemical reaction called the Maillard reaction. The result is a chip that turns dark brown, almost black before it's fully cooked. Dark chips fail quality checks. Entire batches get discarded. So major manufacturers like Lay's and Kettle Brand contract directly with specific farmers, specifying the potato variety, the growing conditions, the fertilizer regime, and even the harvest timing. They take samples from incoming trucks, test the sugar levels, test the dry matter content. If the potatoes don't meet specification, the entire truck can be rejected. The quality control begins in the field months before a single chip is fried. Washing and peeling. Trucks arrive at the factory loaded with raw potatoes still carrying soil, debris, and field. Residue. The first stop is the receiving inspection. Quality teams pull random samples from each truck. Check for green edges, a sign of solanine, a naturally occurring toxin. Check for blemishes, rot, and physical damage. The defective potatoes are weighed. If the weight of rejected potatoes exceeds the factory's preset allowance, the entire truckload is rejected and sent back. Accepted potatoes move onto the conveyor system. First, a stone trap, a vertical helical screw conveyor that allows stones and heavy debris to fall to the bottom while potatoes are carried upward. Stones in the peeling or slicing machines would cause serious damage. They have to go first. Then, high-pressure washing. Rotating brushes and water jets scrub every surface, removing soil, residue, and surface bacteria. Then peeling. Industrial peeling machines use two methods. Abrasive peeling, where potatoes tumble against rough surfaces that grind away the skin, or steam peeling, where high-pressure steam loosens the skin, which is then removed by rollers. After peeling, the potatoes are washed again with cold water, clean, smooth, ready for the most critical stage of the entire process. Slicing, where precision is everything. The peeled potatoes move into industrial slicers, and this stage, more than any other, determines the quality of the final chip. Razor-sharp rotating blades cut the potatoes into uniform slices, typically 0.04 to 0.08 inches thick, that is 1 to 2 millimeters, thinner than most coins. Why does uniformity matter so much? Because every slice goes into the same fryer, at the same temperature, for the same amount of time. A slice that is 0.5 millimeters thicker than the others fries slower, comes out softer in the center, fails. Texture checks. A slice that is 0.5 millimeters thinner fries faster, burns before the batch is done, creates dark chips that fail color checks. Every slice has to be identical, and at factory speeds, these machines are cutting thousands of slices per minute. The blades are monitored and replaced on a strict schedule. A dulling blade doesn't cut cleanly. It compresses and tears the potato, creating uneven edges that fry inconsistently. Ripple-cut chips use specially engineered wavy blades. Crinkle-cut use a different profile. Each blade type is calibrated to produce the exact texture the brand requires. After slicing, the pieces go through a starch wash. Cold water rinses remove the surface starch that was released during cutting. Why? Because surface starch causes chips to stick together during frying, creating clumps, and it makes chips absorb more oil than necessary. Rinse the starch away, and you get a cleaner fry. Crispier texture. Lower oil absorption. The frying, the heart of everything. The washed slices drop into the industrial fryer, and this is where the magic and the science happen simultaneously. The oil temperature is held between 320 degrees Fahrenheit and 375 degrees Fahrenheit. That is 160 to 190 degrees Celsius. The moment the potato slice hits that oil, the water inside the slice begins to evaporate violently. Steam bursts outward through the potato's cell structure as the water leaves the oil, takes its place in the outer layers, creating that rigid, crispy shell. The entire moisture content of the potato slice, which started at around 80% water, drops to approximately 2% in the finished chip. That dehydration is what creates the crunch. Now here's the part nobody talks about. The oil itself is a major quality variable. Most large manufacturers use sunflower, canola, or corn oil chosen for their high smoke, point, and neutral flavor. But oil degrades with use. As potatoes fry, starch, sugars, and proteins leach into the oil. Over time, the oil darkens, develops off flavors, and produces chips with a rancid or stale taste. So, the oil is continuously filtered. Fresh oil is continuously added. The oil turnover rate, how quickly the entire volume of frying oil is replaced, is carefully monitored and controlled. At peak production, the fryer is consuming and recycling thousands of liters of oil per day. At the end of the fryer, a wire mesh belt lifts the chips out of the oil. Excess oil drains off. Immediately, the chips are golden, crispy, and extremely hot. The acrylamide problem, what they're fighting. Here's the thing I promised to explain. The chemical nobody told you about. When starchy foods like potatoes are cooked at high temperatures, a chemical called acrylamide forms naturally. It is a byproduct of the Maillard reaction, the same reaction that creates the golden color and roasted flavor of fried food. Acrylamide has been classified as a probable human carcinogen by the World Health Organization. The EU has set a regulatory limit of 750 micrograms per kilogram for potato chips. Top-tier U.S. manufacturers aim for below 450 micrograms per kilogram. And reducing acrylamide without destroying flavor or color is one of the most active areas of research in the snack food industry. The main levers manufacturers use lower frying temperatures, shorter frying times, specific potato varieties with lower asparagine content, the amino acid that drives acrylamide formation, and the starch wash before frying, which reduces surface sugars. Every major chip manufacturer runs continuous acrylamide monitoring in their quality labs. It is not on the front of the bag, but it is one of the most closely watched numbers in the entire production process. Optical sorting, rejecting the bad ones. After the fryer and the initial cooling conveyor, the chips pass under an optical sorter. This machine uses high-speed cameras and sensors to scan every single chip as it moves along the belt. Any chip that is too dark burned edges, over-fried sections gets rejected. Any chip with an unusual shape, a green patch, or a visible defect rejected. The rejection mechanism is a precisely aimed puff of air hitting the defective chip at exactly the right moment to knock it off the belt without disturbing the chips around it. This happens hundreds of times per minute. At production speed, the optical sorter is making quality decisions faster than any human eye could track. Only the chips that pass the golden, uniformly colored, properly sized ones move forward. To seasoning. Seasoning the flavor science. Plain salted chips go through a salt tumbler, a rotating drum where chips tumble continuously, while salt is sprinkled from above at a precise ratio. At large plants, approximately 1.75 pounds of salt per 100 pounds of chips. But flavored chips, barbecue, sour cream and onion, salt and vinegar, cheese are a different operation entirely. Seasoning blends for flavored chips are closely guarded proprietary formulas. The exact combination of flavor powders, acids, fats, and carriers that create each brand's signature taste are protected as trade secrets. The seasoning is applied in a flavoring drum. Chips tumble through a rotating cylinder while seasoning is dispensed from above. The coating has to be even. Every chip needs the same amount of seasoning on the same surface area. Too much overpowering, too little bland. Inconsistent distribution. Some chips taste strong, others taste like nothing. The flavoring drums are calibrated to hit the exact seasoning percentage specified for each product. After flavoring, one more quality check. Trained sensory panels taste samples from each batch, evaluating flavor intensity, salt balance, texture, and aroma. If something is off, the batch is held. The cause is investigated. Nothing leaves the factory that doesn't pass the taste panel. Packaging, nitrogen, and the bag. Seasoned chips move to the packaging line. And here is something almost everyone notices but nobody understands. You open a bag of chips. It's enormous, filled with air, and the chips are at the bottom. That is not the company cheating you. That is nitrogen gas, and it is protecting your chips. Before sealing, every bag is flushed with nitrogen to displace oxygen, the oxygen level inside. A properly sealed bag drops to below 0.5%. Why? Because oxygen causes oxidation. Oxidation turns the fat in the chips rancid, creates that stale, off flavor you get from an old open bag. Nitrogen is inert. It doesn't react with the chips. It protects them from the oxygen that would destroy their quality. The bags themselves are metallized multi-layer film, typically 3 to 5 layers of different materials, each one contributing to the barrier against moisture, oxygen, and light. Proper packaging extends chip shelf life to 8 to 12 weeks. Every bag passes through a metal detector before it's sealed. Then, a check weigher confirms the bag contains the correct weight. Any bag outside weight specification rejected automatically. Each sealed bag receives a production code that links it to the specific batch, the specific production line, the grower ID, the oil lot, and the seasoning blend used. In the event of a recall, the factory can trace any bag back to its complete production history in under 90 seconds. The full picture: contracted farm, specific potato variety, incoming quality inspection, stone removal, high pressure washing, peeling, slicing to 1 to 2 millimeters, starch wash, frying at 160 to 190 degrees Celsius, oil, management, optical sorting, seasoning and flavoring drums, taste panel, nitrogen flush, multi-layer packaging, metal detection, weight check, full traceability code. From raw potato to sealed bag, approximately 30 to 45 minutes. 5 million tons consumed globally every year. $40 billion industry. And every single bag, whether you bought it in London, Lahore, or Los Angeles, went through this same process, this same precision, this same science. That crunch you love? It took a furious chef, 170 years of industrial development, and a factory running at full speed to put it in your hand. If this video changed how you think about that bag sitting next to you right now, share it with someone who eats chips every week without ever wondering where they came from. See you in the next one.